Welcome to Right Section Samstha Satara Rose Project conducted by Yashwantrao Chauhan Institute of Science Satara. We study about the current through the conductor, and at last lecture we studied about the terminal potential difference, internal potential difference, electromotive force, and internal resistance, external resistance, etc. Now today's lecture we study about the combination of cells. Now when we want to require increase the current capacity or voltage capacity, then these cells are connected in a series or parallel. That is called as the combination of the cell. Now when cells are connected one after another, just like this, positive terminal and the negative terminal of the first cell is connected to the positive terminal of the second cell, and negative terminal of the second cell is connected to the positive terminal of the third cell. This combination is called as the series combination. So when such a types such cells are connected, so the negative terminal of one cell is connected to the positive terminal of the next, etc. And we know that suppose that potential difference of the first cell is 0.5, potential difference across the second cell is also 1.5, and potential difference across the third cell is also 1.5 volt. Then we add this all voltages, means 1.5 plus 1.5 plus 1.5. So total voltage obtained across this series combination is 4.5 volt. So look at this apparatus. This is the first cell, and this first cell, this is the negative terminal of the battery, and this is the positive terminal of the cell. So, and this also second cell, and when we connect just like this, in this way, means negative terminal is connected to positive terminal of the second cell. This combination is called as the series combination. Series, correct? It is a series combination. And in this combination, suppose this cell will be 1.5 and this cell will be 1.5. Then total potential difference across these two cells will be V1 plus V2, and it is equal to near about 3 volt. And in the diagram, there are 3 cells are connected, 1, 2, and 3. So potential difference across this cell is V1 plus V2 plus V3, means it is near about 1.5 volt. This is called as the series combination. Here, potential is increases here, but there is no change in the current in this section. Now, in the series combination, the terminal PD of the battery increases, and it is equal to the sum of the terminal PD of each combination. Therefore, the voltage capacity increases, and a combination gives the same current as that of the one cell, thus the current capacity remains constant or same. And this combination increases the effective value of the internal resistance also. Now, when cells are connected in parallel, what is the parallel combination? Parallel combination just like this. This cell having positive terminal and this also second. When these two positive terminals are connected between these positive terminals connected by a signal wire and take one output, and this negative terminal is connected to a signal wire, and one terminal is take out, then that combination is called as the parallel combination. In the parallel combination, supposed to be 3 cells are connected, and the terminal potential difference is 0.5 volt. And in this diagram, these are the 3 cells: first cell, second cell, and third cell. Having current I which are flowing through the first cell, also I is the current flowing through the second cell, and I is current flowing through the third cell. Then total current which are obtained at point A and B is supposed to be 3I, means these I, this are added to each other, and so total current at point A is supposed to be 3I. And the potential difference is not increased here. So potential difference of first cell is 0.5, second is 0.5, and third is also 1.5. So total potential difference across the point A and this is supposed to be B will be 1.5 volt. There is no change in the potential difference, but change in the current. And previous case, what happened here? Here potentially increases for current is same. तर ह्या सिरीज कॉम्बिनेशन मध्ये काय होतं की इथं आपल्याला पोटेन्शियलचं ऍडिशन होतंय तर करंट तो सेमच राहतोय. करंट मध्ये काय फरक पडत नाही. आणि हे कॉम्बिनेशन आपण आपल्या स्वतःच्या बॅटरी मध्ये वापरतो. वेगवेगळे सेल्स आपण इथं सिरीज मध्ये आपण ते कनेक्ट करतो आणि आपल्याला आउटपुट आहे ते हाय व्होल्टेजचं मिळतं. इथं पॅरल कॉम्बिनेशन मध्ये काय होतंय की आपण जरी सेल हे पॅरल कॉम्बिनेशन जोडलेले असले तरी करंट वाढतोय इथं पण पोटेन्शियल डिफरन्स जो आहे तो सेम राहिला आहे. So this is the difference between a series combination and parallel combination. So we want to increase the potential, then we connect that cell in series, and when we want to increase the current, then we connect that cell in a parallel combination, just like this. This combination gives the current 3 times that of the one cell, thus the current capacity increases. This combination reduces the effective value of the internal resistance. Now, the second part is work done by electric current. Means when a source of electricity is connected across a resistor R, then electric current I is set up in the resistor, and resistor offers a resistance to the flow of current. Now, to overcome the resistance, a cell or a battery perform a work, and this source of electricity provides energy from the work. So terminal potential difference of the source of the electricity is given by the equation work upon time. Means how much work will be done and how much charges. How much charges. This work divided by charge is called the potential difference. Now this so work is equal to potential difference into charge. But we know that the charge, what is by the charge? Charge means current flowing to the conductor divided by into time. So the work is equal to W, means work done, and it is equal to potential difference to V, and charge is supposed to be Q. Now when at the Q means charge, and when time is T, then we find out the current. So current is equal to charge upon time. So charge is equal to current into time. So charge is equal to current into time. Substitute this value in this equation W. So W is equal to V IT. Here, this is the most important equation, which is the work done is equal to potential difference into current and into time. How much time will we use? By using the Ohm's law, V is equal to IR and I is equal to V upon R. Substitute the value of V is equal to IR here. So we get W is equal to I square RT, and we substitute the value of I here. It is V upon R. Then we get the equation V square T upon R. These equations are most important. W is equal to VIT, W is equal to I square RT, W is equal to V square T upon R. Many examples or MCQs are using these formulas. So it is the most important formula, and remember that. Now, this equation means when work is done, the electric current which passes through the resistor, and that resistor will be heated. And due to this heating effect, that is called the heating effect, and the electrical current perform this heating effect, and the heat producer is given by it is equal to H, means work done is converted into heat, and it is equal to H is equal to VIT. This is also it is equal to I square RT is square T upon R square. Now, at the last point, we study about the work in electric circuit. Means what is the work or power in electric circuit? What is the power? Electric power means the rate at which the work must be done by the electrical source. It is called as the electric power. So electric power means work done divided by time. So work done is denoted by capital W, and time is denoted by small t. So power is equal to W upon T. So this small t is taken at the left hand side. So W is equal to VIT, and it is we know that the equation W is equal to VIT. But power is equal to W upon T. So VIT upon T means power is equal to V into I. So we write that power is equal to VI. V means potential difference and current. So power is equal to potential difference into current. So we know that the potential is measured in volt and current is measured in ampere. So the unit of a power is the watt, and it is equal to 1 volt into 1 ampere. Means it is equal to also 1 joule divided by 1 second also. So we define 1 watt or watt. If 1 joule of work is done using this formula, and in 1 second, then that electric power is said to be 1 watt. Means 1 joule is work done in 1 second, then it is called as the 1 watt power. And this is a familiar unit of power. Means when we brought some electrical equipment from the shop, then we said that I want to get 40 power watt bulb, tube, etc. So this is the most important unit of the power, which is called as the watt. Now, what is 1 kilowatt? No, we know that the kilo means 1000. So 1 kilo means 1000 watt. What is my 1 HP? Our electrical water motors are calibrated by horsepower. H means horse and P means power. So 1 horsepower HP, 1 HP is equal to 746 watt. तर 1 horsepower म्हणजे थोडक्यात 746 वॅट आणि 1 किलो वॅट म्हणजे 1000 थोडक्यात वॅट होतं. किलोचा अर्थ 1000 होतो आणि इथं HP जो लॉंग फॉर्म आहे 746 वॅट असा आहे. So we want to obtain a relation between the electric energy and electric power. Electric energy and electric power are different phenomena. The electric power consumed in electric circuit is given by this equation. So electric power is equal to electric work done divided by time. Using this equation, electric work which will be calculated. So electric power into time. That is called the electrical energy. So we write here electric power is equal to electric energy divided by time. So electric energy is equal to electric power into time. Generally, the electric energy measured in kilowatt hour. So kilowatt hour. 1 kilowatt hour means 1 kilowatt into 1 hour. So 1 kilowatt means 1 kilowatt means 1000 watt, 1000 watt into 1 hour means 3600 seconds. So we calculate this 1 kilowatt hour, it is equal to 3.6 into 10 raised to 6 joule. So 1 kilowatt hour means energy is 3.6 into 10 raised to 6 joule. By the definition of 1 kilowatt, when we use electrical appliances operating 1000 watt for 1 hour, then the electrical energy consumed by that appliances is 1 kilowatt hour. Means when we on the bulb and power of that bulb will be 1000 watt and that bulb is used for 1 hour, then that is called as 1 kilowatt, and also it is called as 1 unit. And this is the commercial units used for electrical energy consumed in our house or our shop or our company. Now this energy meter fixed on Maharashtra State Electricity Distribution Company Limited (MSDCL), and it is every house or shop records energy consumed in kilowatt hour or unit. तर आपण जे घरामध्ये आपण वीज वापरतो त्या विजेच्या मोजण्यासाठी बाहेर एक मीटर असतो बघा आपल्या घराच्या बाहेर त्याच्यावर त्याचं युनिट लिहिलं असतं बघा खालच्या बाजूला KWH असं लिहिलं असतं. तर त्याचा अर्थ होत असा होतो की किलोवॅट आवर असा तो आपण त्यामध्ये आपण जी एनर्जी काय कंझ्युम करणार आहे ते किलोवॅट आवर मध्ये आपण मोजतो. So we stop here and our chapter will be end here. MCQs and board type questions are given at below on Google form. To submit that Google form and we need marks. Correct. So thanks to all and we will stop the lecture.